All right, year eights, welcome back. We'll quickly review what you should have learnt last lesson, which was about elements. And I think there was a couple of key properties, and I had you take down some important notes. Those notes were that number one, elements are pure substances because they're made up of only one type of atom. Now, you can have pure substances that are pure compounds, but elements are special because they only have one type of atom inside them. Now, atoms are the building blocks of all matter. We're going to have a bit of a closer look at them today. Examples of elements do include gold and diamond. Gold is made up of only gold atoms, and diamonds are made up of only carbon atoms. And most substances that we encounter day to day are not pure elements. They're actually mixtures or compounds because they're made up of more than one type of atom. Now we're going to build on those ideas today, and we're going to start looking at atoms and how they can be arranged into molecules and lattices. All right, so if you look on sector, you'll see that what I want you to do today is become familiar with what atoms are and how they can be arranged to make molecules or lattices. So to do this successfully, you need to understand that all matter is made up of atoms. We're not necessarily going to get into the subatomic particles, but I want you to understand that all matter is made of atoms. You know that sometimes these atoms will join together in specific combinations. So that means, for example, to make carbon dioxide, you have to have the very specific combination of one carbon and two oxygen atoms to make that carbon dioxide molecule. You also need to be aware that sometimes these atoms join together in a special pattern to make a lattice. So we'll go into that and explain what a lattice is. Let's do that now. All right, so you may or may not have seen this before. This is the periodic table of elements, and I want to draw your attention to these guys over here. Now, if you look at the key in the middle, they're the noble gases. The reason they're called the noble gases is because they don't like to mix. They like to, keep to themselves. So they literally float around as single atoms. So these are going to be the notes for your science books. Please put the title Atoms, Molecules and Lattices. And the first note is going to be, a few elements occur naturally as individual atoms. Examples include helium, neon and argon. They are all noble gases, and it might be useful to get a diagram as well, if I can get this to cooperate. There we go. Showing that it's just a few atoms just happily, they're not bound to each other, they're not attached to each other in any way, they're just happy being atoms. Okay, let's move on to the idea of molecules. Now, molecules are when atoms are bonded together. They can be bonded in lots of different ways, but they're stuck together and they stick together in a certain pattern to make up certain molecules. Sometimes these molecules are small, they're only made of two atoms, for example, oxygen or O2 gas. And sometimes they're quite large. For example, DNA is a molecule that has all the instructions that make you inside your cells. So I dug up a couple of pictures to help demonstrate that. Here we can see we've got two red atoms. They're supposed to be oxygen atoms, and they're stuck together to make O2, oxygen. But over here, we've got a different molecule. And even though it's still made of only oxygen, you can see there's 1, 2, 3 oxygen molecules. Instead, it becomes a different molecule because there's 3 instead of 2. And that molecule is called ozone. So molecules are important to know the ratio of the number of atoms in it because it makes it very different if there's an extra atom or an extra element in it. All right, this yellow stuff over here is sulfur, and you can see that it's actually 8 atoms bonded together. And this is an example of an element that makes up quite a large molecule. It's hard to get an element making a bigger molecule than that, something that's made of only one type of atom. Okay, so the last thing we need to look at is lattices, remembering we're trying to keep it so it's only talking about elements, not worrying about when different atoms get bonded together. Okay, first thing you need to be aware of is that lattices are probably the most common way that you're going to find an element. They rarely form single atoms, and they also rarely form pure molecules. Now, lattices are when lots of atoms are bonded together in a continuous way. So if you have a look here, I've got an example of gold lattice. You can see how it's three-dimensional, and it's very regular. So, there's a certain pattern to how these gold atoms are bonded together. Here's another example showing an iron lattice, and you can see it's a very, very regular structure. It's also in 3 dimensions, and This is just a little snippet. It is actually much, 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 much bigger. Now, metals tend to form lattices. So you can see gold is a metal, iron is a metal. So if you think of that, and this might help you remember that lattices, because all those atoms are locked in, lattices tend to be solid. But if you think, around you in real life, when you encounter metals, they're usually solid at room temperature. I can only think of one example that isn't a solid at room temperature, and that, of course, is mercury. Okay, so quick review. A few elements occur naturally as atoms, and they tend to be the noble gases. Some elements will form molecules, but they can be small, from 2 atoms up to big. But it's really important that, the number and the type of atom in it really determines what it is. And finally, lattices are the most common way to find elements, and they tend to be the metals, so they tend to be solid at room temperature. Can you please make sure that you have those 3 notes into your science notebook? And now that you've watched this video, go ahead onto style and answer the multiple choice questions. But stop when you get to properties. Thanks, guys. Hope you're enjoying lockdown.